Hello everyone, welcome to TrendMiner. Today I'm going to talk about leak detection in crude oil pipelines, mainly in upstream operations. Leakage of oil and gas pipeline may result in serious accidents such as fire, explosions, and combustion, with heavy casualties and huge economic losses. These leakages can be caused by external and internal factors like corrosion, excavation damage, incorrect operations, or equipment failure. Leaks from excavation damage can be prevented via safe digging. Before digging, responsible personnel can make calls and find out whether that's the right location for digging or not. And that's how you can prevent from excavation damages. Leak from corrosion can be prevented by timely maintenance on the outer surface of the pipeline, like painting, polishing, etc. Now let's talk about the third one, which is incorrect operations or equipment failure. Most of these parameters are captured in the data. So subject matter expert can analyze the data and may be able to set up some smart alerts to prevent this from happening. We will see in this video how can we analyze this third scenario in TrendMiner. So currently we are looking at a leak detection dashboard. We have here 1.5 year worth of data. For leak detection, companies use frequency response method. That's very popular. They perform this test weekly or bi-weekly, but there are no guidelines from the government. In this method, sound waves are being used to detect leaks. If there is a leak, it indicates an oscillatory pattern. Here in the dashboard, we see 1.5 years of data, and in 1.5 year we performed total 81 frequency response tests. Out of these 81, 10 were positives, meaning leak was detected in these 10 tests. Out of 10, one is caused by excavation damage due to maybe some civil construction activity. 6 are caused by corrosion, and 3 are caused by equipment failure. We can't do much about first two, but we can certainly take a look at the last one, which is leak due to equipment failure. So let's look at this third scenario. So we can directly go from dashboard to actual analysis platform of TrendMiner, which is Trend Hub. So I can click here. And now we are here in the Trend Hub. We can load these two tags. The first tag is a tag where we are saving these test results. Whether those results are negative or positive, we are saving those results. And the second tag is a mass flow. So basically what crude and how much crude oil is flowing from that pipeline, it is capturing that data. So that's a process data. Okay, so let's look at the 3 equipment failure scenario. So I can perform a search, which is context item search. And we can take a look at this scenario, leak due to equipment failure. And when I say search context item, TrendMiner gives me 3 results here. So 3 events when leak occurred due to equipment failure. The first one is on March 16th. Second one is on September 5th. And the third one is December 17th. And you see the duration 1 second. This is just the test duration because this is the test. It's a very short, it takes very short amount of time. So when I click on the first one, you can see a context bubble comes here. If we click on this context bubble, we can see who created. So in this case, I created this context item. And it says weekly frequency response test for the leak detection. And the result is positive, leak detected due to equipment failure. And if we look at more, then it says leak detected from the expansion joint. So expansion joint is a fitting in the pipeline. So the leak is coming from this expansion joint. And the flow drop is 60 here, you can see. So this is a unit, flow unit. So 60 units of flow is being dropped because of this leak. Let's look at the second result. So in the second result, same thing, but this time leak is detected from T. So T is another fitting, another type of fitting in the pipeline. And here also flow drop is around 60. And let's look at the third one. And the third one, it says leak due to the rupture disk. So rupture disk is basically a relief device which releases the extra pressure. So it says leak is detected from the rupture disk. So basically these different fittings are damaged here. So this is equipment damaged here. In TrendMiner, we can compare these three events and we can find out what happened during these leaks. So for the comparison, what we can do, we can overlay these events on top of each other. So currently we are looking at December 17th event. What I can do, I can overlay September 5th by clicking here, and then I can overlay March 16th by clicking here. You don't see any difference because these events are overlaid on top of each other. So they're very small events. That's why they're kind of overlaid on top of each other. And you can see we are looking at just few seconds of data. So now what we can do, we can quickly go and take a look at 1 day of data. So as I click on 1 day, you can see currently we are looking at 1 day of data and our context item is right here. So what I can do, I can see what is happening in the flow right before the leak. So when I click on the flow, just refreshing my screen so that flow pops up here. As I do that, you can certainly see that we were flowing around 680 and then something happened and flow dropped to around 615, as you can see, 615 or 620 range. So it's a huge drop, and this drop is happening because of the leak, as someone noted here. So now what we can do, we can compare these events. So we can align these events on top of each other. And the aligning point would be this leak. So I can go to the layer menu and I can align these. So September 4th is this layer. So I can shift it to the left. And my reference layer is the base layer, which is December 16th one. And on March 15th, I can shift it to my right. So this is a bigger and a smaller shift. So I'm taking bigger shift here. And then I can shift a little bit to the left. Now it looks like these layers are aligned. Now we can just look at maybe first few hours before the leak and then few hours after the leak. So we can look at around 5 or 6 hours of data. I just zoomed into it. Now we are kind of done with this test tag because it has just the metadata. So let's focus on the mass flow tag. So I'm going to hide this tag for now. And now we are looking at 7 hours of data. So to find out the root cause behind this problem, behind these leaks, we can perform a correlation analysis test here. So I can run recommendation engine. It's a global correlation tool. It goes back to the TrendMiner and looks at all the index tag. And if it sees any tag is highly correlated with our tag of interest, in this case, this mass flow tag, then it's going to give that as a result. And then we can analyze further. So let's run this recommendation engine. And as I run this recommendation engine, one result pops up and it says outlet pressure is highly correlated with the mass flow, and the outlet pressure, it says 98% correlated. That's a huge number. And this outlet pressure is basically the pressure we are detecting outside the pipeline. So I can bring this pressure here. And as I bring the pressure, you can see in the two events, pressure was a little high and then it dropped kind of low. Versus the third event, we had little lower pressure, and then when it dropped because of the leak, it didn't drop that much relative to the other events. But now let's look at just 1 day of time period and see what happened uh, in last day prior to the leak on the pressure side. So when I say 1 day, you can clearly see a huge spike on all three events, and that occurred few hours prior to the spike, prior to the leak. You can see around 4 hours 30 minutes prior to the leak, and it happened on all the layers, and we can certainly go and take a look at each individual events. So if I click on December 16, which is the base layer, you can see this is the base layer. If I click on September 4th, so this is the spike on September 4th one. And then let's look at the March 14th one. So this is the spike on the March 14th one. So it says that prior to the leak, this pressure is spiked. And this pressure is spiked a lot. As you can see, the normal value of pressure is in 30s. Okay, I can add a axis here. So you can see the normal value is in 20s and 30s, but when it spiked, it went up to 500. So that's the limit. It went up to the 500 or more than 500. So that's a huge spike. And this kind of overpressure scenario can be result of internal reactions or incorrect operations. They can cause damage to the pipeline internally or can cause damage to the fittings of pipeline, which result in the leak of crude oil or gas. And exactly this is what happened. Because of these spike, I guess the metal damaged, and because of that we saw leaks from different fittings. Okay, so now we know that pressure is causing the problem. So what we can do in the TrendMiner to prevent that from happening. So in TrendMiner, we can set up an easy alert, a profile-based alert on the pressure tag. So if this kind of event occurs in future, then TrendMiner is going to send us an alert 4 hours or 4.5 hours prior to the actual spike. So let's see how we can do that. So in this case, I'm going to just hide my mass flow tag and I'm going to focus only on the pressure tag. And let's delete other layers and keep the base layer. So this is my base layer. I'm going to zoom into it. And then I'm going to put some emphasis on the spike portion because that's important for me. And I can run Similarity Search. So it's a trend-based search. So if you're looking for a specific pattern, you can run this search. And this search can be run on absolute value or signal shape. In this case, absolute value is important for me. Basically, this is an overpressure scenario, so value is important for me, high values of pressure. And minimum score is a minimum overlapping score, so I'm going to go with 70% in this case. And I can run the search. And as I run the search, I see two results, September 5th and March 15th one. I can save this search. And I can name it overpressure in pipe 37911. Then I can save it. Now this saved search can be used to set up an alert. So I can come here in the monitoring panel. I can enable the search. Provide my email here, and in the subject I can say overpressure or I can say leak. It could be overpressure on pipe 37911, and in the message I can say check or contact operator. I can add a context item, automatic context item from here. And in the component side, maybe I can choose context item to go on the pressure tag. Type would be anomaly, and the description is overpressure pressure might cause leak. And I can add a few keywords here like leak 37911 overpressure, because all these events are searchable via keywords as well, and I can save it. And as I do that, you can see this alert is saved. So now whenever this kind of overpressure scenario comes in, TrendMiner is going to send us an alert, and then we have 4 hours of head start to prior to the actual leak, so we can prevent it from happening. That's it. Thank you very much.